Welcome to Science, to Sleep By, where wonder meets rest. Tonight, we drift beyond our world to explore the silent depths of the Milky Way. Billions of stars shimmer above us, and around many of them, planets quietly orbit unseen, untouched, and full of mystery. So settle in, slow your breathing, and let your mind float among the stars as we ask, how many planets are in our galaxy? When night falls and the hum of the day fades into silence, the sky opens like a grand stage. The stars begin to appear, one by one. Tiny sparks that seem fragile yet ancient, delicate yet endless. Above the cities and quiet countryside, beyond the noise of human life, there stretches a great darkness filled with light. This is the canvas of our galaxy, the Milky Way, arching across the heavens like a river of silver mist. For those who look up with curiosity and calm, the sky whispers a timeless question: how many worlds lie hidden among those distant stars? The question itself feels infinite, echoing in the spaces between the constellations, in the pause between heartbeats, in the stillness of night. The Milky Way is not merely a band of light we see above us. It is the home of our sun, our planet, and perhaps countless others. It is a spiral of stars so vast that even light, moving at 186,000 miles per second, takes over 100,000 years to cross from one side to the other. Imagine that for a moment: light, the fastest traveler in the universe, journeying through an ocean of stars for 100 millennia just to reach the far shore. Every star you see with your eyes, and billions more you never will, exist within that spiral. Each one is a sun in its own right, some larger, some smaller, some burning fiercely blue, others glowing softly red. Around, many of them, invisible to us in the darkness, circle planets, small companions tracing silent orbits as they have for billions of years. If you close your eyes and let your mind drift upward, you can almost sense the motion of it all. The Earth turning beneath you, the solar system spinning within the Milky Way, and the Milky Way itself gliding through the vast expanse of the cosmos. There is a kind of serenity in realizing that even as we rest, the universe moves with perfect rhythm. It is not chaos, it is an ancient patient dance. The galaxy overhead is not just a view. It is a living system, cosmic organism that holds within it the ingredients for life, for stars, for time itself. When astronomers gaze through telescopes, what they see is not simply starlight, it is history. The light that reaches us tonight from the farthest edges of the Milky Way left its source tens of thousands of years ago, traveling across the galactic sea to meet our eyes. That starlight carries stories of formation, destruction, and rebirth. It carries evidence of countless suns that have risen and faded, of planets that may have formed, collided, and reformed again in endless cycles. When you look up, you are not seeing the present sky, you are seeing time itself stretched across the horizon, the memory of the galaxy shimmering in the quiet night. For most of human history, the stars were mysterious fires, lights of gods, or signals of destiny. Only in the last few centuries did we begin to understand that they are sun's vast nuclear furnaces like our own, each capable of hosting its own family of planets. That realization changed everything. It turned the night sky from a celestial map into a vast neighborhood, a place full of potential homes, full of stories untold. Every point of light became a possibility, a whisper that somewhere out there, another Earth might circle another sun. In ancient times, people could only imagine what lay beyond the stars. Today, with telescopes that see farther than human eyes ever could, we know that there are not just a few stars, but hundreds of billions in our galaxy alone. Each one might have its own planets, perhaps even moons, with atmospheres, oceans, or clouds. Some worlds may be icy and dim, others blazing under twin suns. Some may have skies tinted in alien colors, winds that never cease, or mountains made of crystal and dust. Yet, in the stillness of night, all of them are out there, silent, patient, and waiting to be found. The galaxy overhead is more than a sight, it is a feeling. It is the quiet awe of knowing that our planet, with all its life, weather, and dreams, is just one among billions. It is the comfort of knowing that we belong to something vast and beautiful, something that existed long before us and will continue long after. The light that travels from those distant stars is older than our species, older than any story ever told, yet it still reaches us, proof that even across the gulf of space and time, connection endures. If you were to stand beneath the dark sky in the heart of the desert, or atop a mountain far from the city, you would see the Milky Way clearly, a hazy, glowing band stretching from horizon to horizon. It would look almost alive, breathing slowly with the rhythm of your own heartbeat. That is the spine of our galaxy, a great wheel of stars, dust, and gravity that binds us all together. Somewhere near the edge of one of its spiral arms lies our solar system, a tiny cluster of light orbiting quietly around a middle-aged star. And if you imagine each of those other stars having planets of their own, then the number of worlds quickly becomes unimaginable. Think of our own solar system for perspective. One star, our Sun, hosts 8 planets, hundreds of moons, and countless smaller bodies, asteroids, comets, dwarf planets, and fragments of cosmic rock. Now multiply that by the hundreds of billions of stars in the Milky Way. Even if only a fraction of them have planets, the total would be staggering. The galaxy overhead is not just a collection of stars, it is a collection of solar systems, each one unique, each one holding mysteries we have yet to uncover. The night sky, then, is not empty. It is crowded with potential, with motion, with life's raw ingredients, hydrogen and helium, carbon and oxygen, dust and gas, all drifting, colliding, and coalescing into new worlds. Every glimmer of starlight represents a chance, a reminder that creation is constant, ongoing, and endless. Somewhere out there, even now, a new planet may be forming around a newborn star, hidden within a swirling cloud of cosmic dust. The process that once shaped our own Earth continues across the galaxy in silence, painting the universe with possibility. As you breathe deeply and let your thoughts wander among those distant suns, you might feel a sense of humility, but also belonging. We are not outside the galaxy looking in. We are part of it. Our atoms were forged in ancient stars. Our world was built from cosmic dust, and our lives are carried on the same gentle laws of physics that govern the stars above. The galaxy overhead is our origin story, written in light, a story billions of years in the making. And as you gaze upward, it's worth remembering that those tiny pinpoints of light are not lonely. Around them orbit unseen companions, planets, perhaps moons, perhaps even worlds where alien skies shimmer with unfamiliar constellations. Some of them may be barren and cold, others warm and blue, and a few, just maybe, alive. Every flicker of starlight could be a sun rising over another world. Every speck of brightness might cradle oceans, mountains, or winds we have never felt. The night above is full of secrets, and yet, somehow, it feels peaceful. The galaxy does not rush. It unfolds in its own time, carrying us along gently through the cosmos. When you lie beneath the stars, it becomes easier to forget the boundaries of Earth, of nations, of daily worries. All that remains is the quiet vastness and the soft truth that we are part of something endless, something luminous. The galaxy overhead, infinite and serene, continues to turn as it always has, scattering light across the sleeping Earth, whispering softly of the countless worlds hidden among the stars. Milky Way is more than the faint band of light we see stretched across the sky on a clear night. It is the vast and intricate system that cradles our very existence. Every atom in your body, every molecule of air you breathe, every ray of sunlight that warms the Earth comes from within this sprawling galactic family. When you step outside and gaze upward into the night, you are not looking at something distant or separate from yourself. You are looking into the heart of your home, a home so vast and ancient that its boundaries defy imagination. Our galaxy, the Milky Way, is what astronomers call a barred spiral galaxy. If we could step outside it and look back, we would see a glowing disk of stars with elegant arms spiraling outward, wrapped around a bright central bar of light. This magnificent wheel of stars stretches about 100,000 light-years from side to side. A single light-year, the distance light travels in a year, is nearly 6 trillion miles. To cross the Milky Way from one end to the other, light would need to travel for 100,000 years without stopping. And even then, it would only have traced a single path across one galaxy among countless others. Inside this great spiral are more than 200 billion stars, maybe even 400 billion or more, depending on how you count the dimmest and faintest among them. Each one burns with its own light and heat, its own gravity, its own story. Around many of those stars, invisible to our eyes, orbit planets, gas giants, rocky worlds, icy spheres, and strange planets unlike anything our minds can fully imagine. Together, these stars and their planets form a glowing, gravitational family, bound by the pull of the galactic center, where something extraordinary lies waiting. At the heart of the Milky Way sits a supermassive black hole, a mysterious and invisible force known as Sagittarius A. It has a mass more than 4 million times that of our Sun, yet it fits within a space smaller than our solar system. Around it, stars whirl at incredible speeds, moving so quickly that their orbits can be measured in mere years rather than millennia. This central black hole anchors the galaxy, holding it together through gravity, shaping its structure, and influencing its evolution. It is both a destroyer and a creator, a paradox that lies at the center of our cosmic neighborhood. The Milky Way's arms are regions of creation, great clouds of gas and dust where new stars are born. Astronomers call them stellar nurseries, and they are scattered like jewels throughout the spiral arms. Within these clouds, gravity gathers hydrogen atoms into clumps, heating them until nuclear fusion ignites and a new sun bursts into life. Around these newborn stars, disks of gas and dust swirl, coalescing into planets, moons, and comets. Every world that has ever existed, including our own, began in such a cradle of cosmic dust. Even as you sleep beneath the stars, new systems are forming somewhere in the Milky Way, silent and unseen. Continuing the endless cycle of creation, our solar system resides about 27,000 light-years from the galactic center, near the inner edge of one of the Milky Way's spiral arms known as the Orion Arm. From this vantage point, we are like passengers on the outer rim of a great cosmic wheel, traveling around the center at a speed of about 500,000 miles per hour. Yet despite this unimaginable speed, it takes our solar system about 230 million years to make a single orbit around the galaxy. That means since Earth first formed, our planet has completed only about 20 full orbits of the Milky Way. The dinosaurs roamed the Earth just one galactic year ago. Our entire history, from ancient civilizations to modern technology, has unfolded in the blink of a galactic eye. The Milky Way is not isolated. It exists within a local cluster of galaxies, a small community in the vast cosmic web. Nearby are our galactic neighbors, the Andromeda Galaxy, our closest large companion, and the smaller Magellanic Clouds that drift like faint smudges of light visible from the southern hemisphere. These galaxies, like islands of stars, move through space under the influence of gravity, destined one day to meet. In roughly 4 billion years, the Milky Way and Andromeda will collide, merging into a new, larger galaxy, sometimes nicknamed Milkomeda. Though the word collision sounds violent, the distances between stars are so vast that very few will actually touch. Instead, the two galaxies will swirl together like ink in water, reshaping themselves into a new form. And in that transformation, new stars and planets will be born. From Earth, the Milky Way looks serene, but within it, everything is in motion. Stars orbit the galactic center, planets circle stars, moons dance around planets, asteroids drift in long looping paths. Even the interstellar dust between stars flows in currents driven by supernova explosions and galactic winds. Nothing in the Milky Way is still. It is a living system, breathing in the rhythm of cosmic time. Over billions of years, stars are born, shine, and die, scattering heavy elements into space. The same elements that later form new worlds and new life. Every atom of iron in your blood and calcium in your bones was once forged in the heart of a dying star that exploded long before the sun was born. When we look up at the Milky Way, what we see is not the full structure of our galaxy, but the combined glow of billions of distant stars whose light merges into a hazy band. Through a telescope, this band resolves into countless pinpoints of light, too numerous to count. The view is humbling, even for scientists who study it daily. We are part of something immense and intricate, yet it feels strangely intimate, as if the galaxy itself watches over us like an ancient guardian. The same gravity that holds the stars in place also binds our feet to the Earth. The same forces that ignite suns also sustain the warmth that nurtures life here. Our understanding of the Milky Way has grown through centuries of exploration and discovery. Early astronomers thought the band of light was a celestial river or the pathway of gods. Galileo, turning his telescope to the heavens in the early 17th century, was the first to realize it was made of countless stars. Later, scientists used radio telescopes and infrared detectors to see through the dust that hides the galactic center from visible light. With each new technology, we peeled back another layer of the galaxy's mystery, revealing not only its shape, but its history. A history that stretches back more than 13 billion years to the earliest days of the universe. In that long timeline, our solar system is relatively young, only about 4.6 billion years old. The Milky Way had already seen the birth and death of countless generations of stars before our sun even existed. And yet, it continues to evolve. Stars still form, planets still take shape, and the great spiral continues its slow, steady rotation through the universe. The galaxy is ancient, but not old. It is still alive, still changing, still expanding in its quiet cosmic rhythm. When you think of the Milky Way, it is easy to imagine distance and scale the vast reaches between stars, the enormous span of the spiral arms, the dizzying number of suns. But there is also closeness, a deep connection that runs through it all. The Milky Way is not just where we live, it is what we are made of. Its dust became our mountains, its elements became our oceans, its light became our energy. To understand the galaxy is to understand ourselves, to see that every breath we take is part of the same cosmic cycle that began long before humans existed and will continue long after. The Milky Way is a home that none of us can ever fully explore, yet one we all belong to. From the smallest particle to the largest star, every component plays its part in the galactic story. The spiral arms carry the light of creation, the center holds the mystery of gravity, and the stars, scattered like seeds in the dark, promise endless possibilities. The galaxy surrounds us, holds us, and carries us through time and space, silent and steady. Its countless suns glowing softly like embers in the eternal night long before any planet existed. Before mountains or oceans or life could take root, there was only dust and gas drifting silently through space. These clouds of matter, vast and cold, stretched for light years across the emptiness, leftovers from stars that had lived and died long before. Within these clouds, the story of every world begins, a quiet and patient process of transformation. This is the birth of planets, the way the universe turns chaos into order, darkness into light, and dust into living worlds. If you could travel back in time to the earliest days of our solar system, you wouldn't see a sun or planets as we know them today. Instead, you would find yourself floating inside a giant rotating cloud, a nebula made mostly of hydrogen, helium, and traces of heavier elements like carbon, oxygen, and iron. These elements were the ashes of older stars, recycled material scattered across the galaxy by powerful supernova explosions. Gravity, the unseen sculptor of the cosmos, began to gather these scattered particles together. Over millions of years, small regions of the nebula grew denser, pulling in more matter and heating up as they collapsed. At the center of this growing mass, where pressure and temperature climbed to staggering levels, nuclear fusion ignited. The first flicker of starlight was born. That newborn star, which would one day become our sun, began to shine, pushing away the surrounding gas and dust with waves of energy. But not everything was cleared away. Around that young sun, a flat, spinning disk of leftover material remained. Within this protoplanetary disk, the seeds of planets took form. Imagine looking at that disk from afar. A golden ring of dust circling a bright central flame. Within that ring, tiny grains of rock and ice began to collide. Some bounced apart, but others stuck together through weak electrical forces. Over time, these tiny clumps grew larger, merging into pebbles, then boulders, then objects kilometers wide. The collisions were frequent and violent, but also creative. Each impact allowed matter to fuse into something new. Slowly, the fragments became planetesimals, the building blocks of planets dot in the inner part of the disk. Close to the young sun, temperatures were too high for volatile substances like water or methane to remain solid. Here, rocky planets began to form, made mostly of metals and silicates. Mercury, Venus, Earth, and Mars would one day emerge from this region. Farther out, where it was colder, ices could survive. Here, the outer planets Jupiter, Saturn, Uranus, and Neptune took shape, collecting massive envelopes of gas around their solid cores. The difference in temperature across the disk determined what kind of planets would form. Where? A cosmic arrangement that continues to define our solar system today. As these early worlds grew, they competed for material, sweeping up debris and clearing their orbits. Some merged into larger bodies, while others were shattered in colossal impacts. One such collision, billions of years ago, is believed to have created our moon. A Mars-sized body struck the young Earth, and the debris that was thrown into orbit eventually coalesced into a smaller companion. This process of destruction and creation played out countless times throughout the solar system, sculpting planets, moons, and asteroids into their final forms. Planet formation is not a quiet affair. It is an orchestra of motion and energy. Dust particles swirl in spirals, gas flows in currents, and magnetic fields twist through the plasma. Yet even within this chaos, order emerges. The laws of physics, gravity, momentum, thermodynamics guide the process with precision. Every planet, every moon, every ring is a product of these same universal forces working together in perfect harmony. The same rules that shaped the Earth are at work in distant galaxies, forging new worlds in the same ancient pattern. Our understanding of how planets form comes not only from studying our solar system, but also from observing others. Modern telescopes, like the Atacama Large Millimeter Array in Chile and the James Webb Space Telescope, allow astronomers to peer into distant protoplanetary disks around young stars. What they see confirms the theory: swirling rings of dust and gas, gaps where planets are forming, and shadows cast by growing worlds as they orbit their stars. Some of these disks are just a few million years old, caught in the act of creating new solar systems. It is like watching cosmic history unfold in real time. Even as planets take shape, their fates are uncertain. Some may migrate inward, drawn closer to their stars by gravitational interactions with the disk. Others may be flung outward into the cold, dark, becoming rogue planets drifting through interstellar space without a sun to warm them. The architecture of a planetary system is delicate, balanced by invisible forces. A small change in one orbit can ripple outward, reshaping the entire system over time. The solar system we see today, with its 8 planets and stable arrangement, is the result of billions of years of gravitational negotiation. Beyond the mechanics, there is poetry in the process. From dust to planet, from gas to sun, the transformation speaks of continuity, of matter reshaping itself across eons. The atoms that make up your body once drifted in such a nebula, waiting to be gathered into something more. The calcium in your bones, the carbon in your cells, the iron in your blood, all of it was forged in stars that lived and died long before our own. Planet formation is not just a scientific process. It is a reminder that everything is connected. The birth of worlds is also the birth of the ingredients for life. As the planets settled into their orbits, the disks that birthed them slowly dissipated. The solar wind from the young sun blew away the remaining gas, leaving behind a system of planets, moons, and smaller bodies bathed in light. Over time, these planets cooled, their surfaces hardened, and their atmospheres took shape. On one small, blue world near the center of the habitable zone, the conditions happened to align in just the right way. Water condensed into oceans, the atmosphere thickened, and life began its slow ascent. The same forces that formed the planets had also set the stage for something entirely new: consciousness, curiosity, and the ability to look back at the stars and wonder how it all began. When scientists study exoplanet worlds beyond our solar system, they find the same patterns repeating. Every star with a disk of dust and gas is a potential cradle of planets. Some systems have giant worlds close to their stars, others have multiple Earth-sized planets orbiting in tight harmony. The diversity is staggering, yet the process is universal. Wherever there is dust, gas, and gravity, planets will form. The galaxy is filled with them, billions upon billions of worlds born from the same cosmic cycle that once shaped our own. From stars to planets, the story of creation is one of patience and inevitability. It unfolds slowly, almost imperceptibly, over millions of years, yet the results are breathtaking. Every world, whether barren or full of life, begins as a whisper of dust in the dark, pulled together by the same forces that bind the galaxies. When you look up at the stars, you are witnessing countless such stories in progress, each one a testament to the universe's quiet creativity, each one a reminder that even in the vast emptiness, something beautiful is always being born. For most of human history, the stars were distant mysteries, unreachable and unchanging. People looked up and imagined them as lanterns hung upon a cosmic ceiling, their faint light offering comfort, but no clues about what lay beyond. The idea that other stars could have planets orbiting them, worlds perhaps like our own, was a dream left to imagination, poetry, and philosophy. Science had no proof, no evidence to confirm or deny it. We knew our solar system, and that was all. Then, in the early years of the 21st century, that all changed. The sky became alive with possibilities. When a silent machine drifting high above the Earth opened its electronic eye toward the stars. Its name was Kepler. The Kepler Space Telescope, launched by NASA in March 2009, was designed with one purpose: to find planets orbiting other stars. Before Kepler, astronomers had discovered only a few hundred exoplanets, most of them large and close to their stars, hot Jupiters, worlds too massive and too hot to resemble Earth. These early discoveries hinted that planets might be common, but no one knew for sure. Kepler's mission was to answer that question with precision. For 4 years, it watched a single patch of the sky in the constellations of Cygnus and Lyra, a region filled with more than 150,000 stars. Day after day, it stared without blinking, measuring the brightness of each star with extraordinary accuracy. The technique Kepler used was deceptively simple, but incredibly powerful. When a planet passes in front of its star, it blocks a tiny fraction of the star's light, causing a temporary dimming. By recording these faint dips in brightness, scientists could detect the presence of a planet, even one smaller than Earth, hundreds or thousands of light years away. Each dip, called a transit, was like a fingerprint, revealing the planet's size, orbit, and distance from its star. The telescope didn't take pictures of planets. It watched shadows, measuring the whispers of light as they flickered across space. It was a quiet form of exploration, more like listening than seeing, but it opened a door that had been locked for all of human history. As data poured in, the discoveries multiplied. At first, scientists found giant planets, their transits easy to spot. Then came smaller ones, rocky worlds orbiting dim red dwarfs or suns, much like our own. Within a few years, Kepler had identified thousands of potential exoplanets, more than anyone had dared to imagine. The numbers were staggering. By the time the mission ended, Kepler had confirmed over 2,600 exoplanets and revealed more than 5,000 strong candidates waiting to be studied further. But perhaps its greatest revelation was statistical. Planets are not rare. They are the rule, not the exception. For every star in the Milky Way, there may be at least one planet. That means our galaxy could hold hundreds of billions of worlds. This realization changed everything. The night sky, once a field of distant suns, became a field of solar systems. Every point of light was no longer just a star, but a potential host to planets, perhaps with clouds, oceans, mountains, and moons. The Milky Way transformed in our understanding from a collection of stars into a vast cosmic ecosystem of worlds. And within that revelation came a deeper question: how many of those planets might be like Earth? Among Kepler's discoveries were several remarkable candidates for what scientists call the habitable zone, the region around a star where temperatures might allow liquid water to exist. Planets like Kepler 22b, Kepler 186f, and Kepler 45b captured the public's imagination. They were Earth-like in size and orbit, orbiting their stars in that delicate balance where warmth and light could nurture life. Kepler 186f, for instance, was the first Earth-sized planet found in a habitable zone. It orbits a small red star about 500 light-years away, and though we cannot yet know its atmosphere or surface, its very existence is enough to stir wonder. For the first time, humanity had concrete proof that worlds similar to ours are out there, orbiting other suns in the galaxy. The beauty of the Kepler mission lies not only in its discoveries, but in its method, its patience, its silence, and its humility. The telescope was like a monk of science, meditating on starlight, recording the faintest flickers without interruption. It did not seek the dramatic or the visible. It sought consistency, patterns, and quiet truth. From this devotion came an understanding that the universe is filled with worlds of every size and temperature, some so close to their stars that their skies are molten, and others so far that their surfaces are frozen in perpetual twilight. It revealed planets with two suns, planets that orbit dead stars, planets that rain iron, and planets with atmospheres so thick that sunlight never touches the ground. Each one was a revelation, a new note in the cosmic symphony. Kepler also revealed the astonishing diversity of planetary systems. Our solar system, with its orderly arrangement of small rocky planets near the Sun and large gas giants farther away, turned out to be only one of many possible configurations. Some systems have multiple planets packed tightly together, their orbits shorter than a week. Others have giant planets that circle their stars in eccentric, looping paths. There are systems where planets orbit in resonance, their movements locked in perfect mathematical rhythm. This variety suggests that the process of planet formation is both universal and creative, capable of producing endless variations on a theme. The universe, it seems, loves to experiment. The success of the Kepler mission also marked the beginning of a new era in astronomy, the era of exoplanet science. Following Kepler, new telescopes and instruments were developed to study these distant worlds in more detail. Missions like TESS, the Transiting Exoplanet Survey satellite, now scan the entire sky for nearby planets, while the James Webb Space Telescope peers into their atmospheres, searching for signs of life. Ground-based observatories use radial velocity measurements to weigh planets and understand their compositions. Together, they have turned the search for exoplanet from speculation into a thriving field of discovery. Yet, in many ways, it all began with Kepler's quiet watch. The Kepler Space Telescope itself faced challenges during its journey. After several years of successful observation, mechanical failures threatened to end the mission early. Two of its four reaction wheels, which kept it stable and precisely aimed, stopped working. Engineers, refusing to give up, devised a clever solution. By using sunlight as a kind of counterbalance, they stabilized the telescope enough to continue operating under a new mission, known as K2. This ingenuity extended Kepler's life for several more years, allowing it to continue gathering valuable data. Even as its mechanical parts aged and its fuel ran low, it remained a faithful observer of the stars until it finally went dark in 2018, drifting silently through space, a monument to human curiosity. The legacy of Kepler is profound. It taught us that the galaxy is alive with planets, that nearly every star we see likely has companions, and that the question of whether we are alone is not just philosophical, but empirical. Somewhere among the billions of worlds Kepler hinted at, there may be one with oceans and clouds, forests and winds, perhaps even life that looks up at its own sky and wonders if anyone else is out there. Kepler gave us the first step toward answering that question, not through fantasy or hope, but through light and data. When we look at the stars now, we do not see distant, lifeless points. We see potential places where the story of creation has repeated itself countless times. We see orbits, climates, and atmospheres that we cannot yet touch, but can imagine. We see the possibility of endless diversity, endless life, of endless beginnings. Kepler's revolution was not only scientific, but emotional. A reminder that our small blue world is part of a grander narrative, one that stretches far beyond the boundaries of our solar system and into the heart of the Milky Way, where billions of worlds may be waiting in the quiet, distant glow of their stars. Trying to count the number of planets in our galaxy is like trying to count the grains of sand along an endless shore. Every handful reveals more than the last, and the further you look, the more infinite it seems to become. For centuries, humanity looked up at the stars and saw mystery. Now, we look up and see statistics, vast, humbling, poetic numbers that reveal just how rich and crowded our universe truly is. Yet even in this age of powerful telescopes and precise instruments, when scientists speak of how many planets exist in the Milky Way, they do so with a sense of awe. Because the number they describe is not merely large, it is beyond the scale of imagination. The journey toward estimating the number of planets in our galaxy began with a single idea. If planets form naturally around stars, then perhaps most stars have planets of their own. Before the 1990s, this was only a theory. Our solar system was the only example we knew, and astronomers debated whether it was typical or a cosmic anomaly. But as technology advanced, instruments sensitive enough to detect the faint tugs or subtle dimming of distant stars began to find other worlds. First one, then dozens, then hundreds. Then came the Kepler Space Telescope, which watched over 150,000 stars and revealed thousands of exoplanets. From those discoveries, astronomers were able to do something astonishing. They could estimate how many planets might exist across the entire galaxy. Kepler's data showed that planets are not rare. In fact, they are incredibly common. Nearly every star in the Milky Way likely has at least one planet, and many have entire systems of them. Astronomers analyzed Kepler's sample and extrapolated from what it saw in one small patch of the sky to the rest of the galaxy. What they found changed our perception of the cosmos forever. If the Milky Way has roughly 200 to 400 billion stars, and most of those stars host planets, then the total number of planets must be staggering. Somewhere between 100 billion and 400 billion, possibly even more. And that estimate might still be conservative. But numbers in astronomy are rarely so simple. Not all stars are the same, and not all have the same capacity to form planets. Some are massive, burning out quickly and leaving little time for planets to develop. Others are small and cool, like red dwarfs, which make up about 70% of the galaxy's stars. These dim little suns live for trillions of years, and often have systems of tightly orbiting worlds. Many of the exoplanet Kepler found circle red dwarfs, which suggests that if these stars are so abundant, then most of the galaxy's planets may orbit them. That alone would mean the Milky Way teems with worlds far more than we could ever count or visit. Among all these planets, scientists are especially interested in those that might resemble Earth, rocky, roughly our size, and orbiting within the so-called habitable zone, where conditions might allow liquid water to exist. Using Kepler's discoveries as a guide, researchers estimate that about 1 in every 5 Sun-like stars has an Earth-sized planet in its habitable zone. If that ratio holds true across the galaxy, then there could be tens of billions of potentially habitable planets in the Milky Way alone. Imagine that for a moment, tens of billions of places where the chemistry of life could take hold, where oceans could form, where skies might be blue, or green, or violet, and where something might look up and wonder about the stars as we do, The act of counting planets is both a scientific and philosophical endeavor. It begins with data light curves, orbital periods, transit depths, but it leads to something much larger, a perspective. The numbers we calculate are not just statistics. They are a measure of how fertile the universe is, how easily it gives rise to worlds. Each estimate brings us closer to understanding the scale of creation. Even if our instruments cannot detect every planet directly, we can infer their presence through probability and pattern. For every world we discover, there are likely thousands more hidden in the dark, orbiting faint stars we cannot yet see. And then there are the rogue planets, worlds that drift through space without a star to call home. These lonely travelers may have been born in solar systems and later ejected by gravitational interactions, or they may have formed on their own out of collapsing clouds of gas. Detecting them is difficult because they do not shine, but gravitational lensing and other techniques suggest they could be as numerous as the stars themselves. If that is true, then the number of planets in the galaxy could double, or even triple, beyond current estimates. There may be hundreds of billions of unbound worlds wandering silently between the stars, frozen and dark, carrying their own stories through the cold cosmic void. To visualize these numbers. Consider this: if the Milky Way has 300 billion stars, and perhaps 400 billion planets, then on average, every star has more than one planet. But planetary systems can vary widely. Some stars may have a single planet. Others may host 10 or more. Our solar system alone contains 8 planets and a multitude of moons, asteroids, and dwarf planets. If even a fraction of the galaxy's stars have similar systems, the number of worlds becomes almost incomprehensible. The Milky Way transforms from a simple band of light into an ocean of planets, each one unique, each one following its own path around its sun. Numbers alone, however, cannot convey the feeling of such abundance. They are scaffolds for the imagination, placeholders for wonder. When astronomers speak of hundreds of billions of planets, they are not just describing quantities, they are describing possibilities. Each planet is a potential environment, a place with its own sky, weather, chemistry, and history. Some may be barren and lifeless, some might shimmer with alien oceans, and some might be too strange for us to comprehend. The numbers remind us that we are not the exception, but part of a vast continuum of creation. Even with the most powerful instruments, our view of the galaxy is limited. We have explored only a tiny corner of it, a small region around our own star. Yet from this small sample, we can glimpse the immensity of what lies beyond. Astronomers use statistical modeling, computer simulations, and the principles of probability to estimate the unseen. They compare star types, measure metallicity, the abundance of heavy elements needed to form rocky planets, and analyze patterns in planetary distribution. The more we learn, the more we realize that the Milky Way is not just filled with stars, but with planetary systems as diverse and numerous as snowflakes in a storm. Future missions will refine these numbers even further. The James Webb Space Telescope is already peering into the atmospheres of distant worlds, detecting molecules that may hint at life or habitability. The European Space Agency's Gaia mission maps the positions and motions of over 1 billion stars, helping to reveal where planets are most likely to form. Upcoming observatories like Plato and Nancy Grace Roman Space Telescope will continue Kepler's legacy, broadening our senses of the galaxy's worlds. With each new discovery, the estimates will grow sharper, but the sense of wonder will remain the same, because even the most precise number cannot capture the enormity of what it represents. When scientists try to express the total number of planets, they often say hundreds of billions, but those words are almost meaningless without context. Imagine counting one planet every second. Even if you did so non-stop, without sleep or pause, it would take you more than 10,000 years to count to just 300 billion. That is the scale of the Milky Way's planetary population, a number so vast that the human mind can only grasp it through analogy, a number that turns the galaxy into something alive and boundless. To count the uncountable is not only a mathematical pursuit, but a reflection of human curiosity. We measure the stars not because we expect to reach them all, but because understanding their vastness reminds us of our place within the universe. The galaxy's billions of planets tell a story of abundance, of a cosmos that creates endlessly, effortlessly, without hesitation. Every world discovered adds one more note to that story, one more line in the quiet poem written across the dark. And though we may never know the exact number, the truth is already clear. The Milky Way is overflowing with worlds, far beyond what we can ever hope to count. When we imagine planets beyond our solar system, our minds often drift toward the familiar worlds like Earth, blue and green, with clouds drifting across the sky, and oceans shimmering under the light of a star. Yet, as astronomers peer deeper into the galaxy, the reality that unfolds is far more astonishing, complex, and at times, surreal. The worlds we've discovered out there are both strange and beautiful, defying what we once thought possible. They are places of wonder, diversity, and extremes. Worlds that expand our imagination and deepen our understanding of what it means to be a planet in this vast galaxy. Each exoplanet, as we call them, tells a different story. Some are scorching giants, orbiting so close to their stars that a year lasts only a few days. Others drift in the frigid darkness, far from any light, where the temperatures drop to hundreds of degrees below zero. There are planets that rain molten iron, and others where winds blow faster than sound. Some orbit not one, but two suns, bathing their skies in twin sunsets, like something out of a dream. Every discovery reveals another chapter in the cosmic narrative of variety, proving that nature's imagination is far greater than ours. The first strange planets discovered took scientists by surprise. Before the 1990s, we assumed that other solar systems would look much like our own. Rocky planets near the star, gas giants farther away, everything following a neat, predictable pattern. Then came 51 Pegasi b, the first confirmed planet around a sun-like star. It was a gas giant, about half the size of Jupiter, but orbiting so close to its star that it completed a full revolution in just 4 Earth days. Temperatures there soared to over 1,000 degrees, and it was so near its star that it was tidally locked, with one side perpetually scorched in daylight, and the other trapped in endless night. It didn't fit any known model, so astronomers gave this new category of planets a name: hot Jupiters. Hot Jupiters are some of the most dramatic worlds we've found. Imagine standing on such a planet, if it were even possible to stand at all. The skies would be filled with glowing clouds of vaporized metals, the light from the nearby star turning everything into a blinding gold. Winds might whip across the atmosphere at thousands of miles per hour, moving heat from one side to the other. Some even have exotic weather like the planet HD 189733b, where scientists believe it rains molten glass sideways, driven by supersonic winds. These planets remind us that what we call extreme is merely relative. In the galaxy, they are just another form of normal, but not all discovered worlds are infernos. Some exist in the icy reaches far from their stars, cold and silent, with surfaces frozen solid. There are planets made mostly of water, covered entirely in global oceans hundreds of miles deep. Others might be carbon-rich, with surfaces of graphite or even diamond. Imagine a planet where mountains sparkle with crystal peaks, where the landscape is sculpted from black stone and silver light. These are not scenes from fantasy, but predictions based on the chemistry and physics of planetary formation. In the vastness of the Milky Way, where billions of stars each host their own worlds, nearly every conceivable variation must exist somewhere. The diversity of exoplanet extends to their orbits as well. Some planets travel around their stars in perfect circles, while others move in stretched, elongated paths that take them from burning heat to freezing cold during each revolution. There are planets that orbit pulsars dead, rapidly spinning stars that emit intense radiation. These worlds, scorched by bursts of energy, are unlike anything in our solar system, yet their discovery proves that planets can endure even in the most hostile environments. Then there are planets with multiple suns, such as Kepler 16b, which orbits 2 stars at once. If you stood on its surface, you would see not one sunrise, but two twin orbs climbing together across the sky, painting the landscape with double shadows and shifting light. And still, there are those worlds that exist between the strange and the familiar, planets that may remind us, just slightly, of home. Kepler 452b, often called Earth's older cousin, orbits a star similar to our Sun and lies within the habitable zone, where liquid water could exist. It's about 60% larger than Earth, and though we don't yet know if it has an atmosphere, it sparks the imagination. There's also Proxima Centauri b, orbiting the nearest star to our solar system. Only about 4 light-years away, it sits in its star's habitable zone and could, under the right conditions, host temperate climates. These worlds give us a glimpse of the possible that out there among the billions of stars, there might be countless planets with oceans, clouds, and maybe even life. Some exoplanets have atmospheres filled with chemicals that create alien skies. The planet WASP-12b, for instance, absorbs nearly all light that falls on it, making it appear black as ink. Others, like GJ504b, are young and still glowing with heat, shining in soft shades of pink. These colors, so different from anything we see on Earth, come from different compositions of gases, pressures, and temperatures. When we study these planets through spectroscopy, splitting the light from their atmospheres into its components, we can detect the fingerprints of elements like hydrogen, methane, carbon dioxide, and even water vapor. Each discovery adds more to the gallery of worlds that nature has painted across the cosmos. Among the strangest are the super-Earths and mini-Neptunes, planets larger than Earth, but smaller than Neptune. Some are rocky, others gaseous, and their sheer variety has puzzled scientists. These sizes don't exist in our solar system, suggesting that our neighborhood might actually be unusual compared to the galactic norm. In other systems, such planets are common, orbiting in tight, compact formations. Some might have thick atmospheres trapping heat, while others could be stripped bare by stellar radiation. A super-Earth might have gravity twice or 3 times that of Earth, making walking there a slow, heavy experience. Yet these planets may also be the most likely to harbor life. Balance between the stability of rock and the protection of atmosphere. The variety doesn't end there. There are planets that orbit so far from their stars that they take centuries to complete one revolution. There are worlds with tilted axes, creating extreme seasons, and others where the axis hardly tilts at all, leaving one face locked in perpetual twilight. Some are dense and compact, made mostly of metal, while others are puffy and light, with atmospheres so bloated they nearly touch their stars. Astronomers have found planets so close to their suns that they are literally evaporating, losing their atmospheres into space. These are called Chthonian planets, the exposed cores of once mighty gas giants, now stripped down to rocky remnants, glowing red-hot from the heat. And then there are the rogue planets, those that wander freely through the galaxy without a star to orbit. They are the loneliest of worlds, drifting in darkness, invisible except when they pass in front of distant starlight. Some might have formed around stars and been flung out by gravitational chaos. Others may have formed in isolation from the start, collapsing directly from clouds of gas. They are cold, silent, and nearly impossible to detect, yet some astronomers believe there could be as many rogue planets as there are stars. Hundreds of billions of worlds adrift in the interstellar night. All of this paints a portrait of a galaxy alive with diversity, creativity, and constant motion. From infernal skies of molten rain to endless oceans of frozen methane, from twin sunsets to the pink glow of a newborn planet, every discovery deepens the mystery. The Milky Way is not a uniform collection of stars, but a grand cosmic experiment in possibility. Planets form wherever conditions allow around massive blue stars, tiny red dwarfs, even the corpses of exploded suns. Each one evolves differently, shaped by gravity, chemistry, and time. What makes this diversity even more astonishing is that we've only just begun to explore it. The exoplanet we know about number in the thousands, yet they represent only a fraction of what exists. Most are too far, too dim, or too small for us to detect. The tools we have today can only see the largest, brightest, or most conveniently positioned examples. With every improvement in technology, with every new telescope and technique, the catalog grows. And as it grows, it challenges our assumptions about what planets can be, what life might look like, and what the word normal really means in a universe as vast as ours. To imagine these strange and familiar worlds is to stretch the boundaries of human thought. Somewhere, perhaps thousands of light years away, there might be a planet with purple grass beneath a dim red sun. Somewhere else, storms might rage forever under skies of glowing hydrogen. And somewhere, way closer than we think, a quiet blue-green world might circle a small, gentle star, its surface touched by rain and wind, its oceans stirring with life force. As long as humans have looked to the heavens, the question has lingered like a quiet hum in the back of the mind. Are we alone? It is a question that crosses time, culture, and science, threading through ancient stories and modern laboratories alike. In every era, beneath every sky, people have wondered whether somewhere among the stars, there might be another world like ours. A place where light falls through an atmosphere, where water flows, where life, in some form, stirs and breathes. The search for another Earth is not merely about astronomy. It is a reflection of our longing to belong to something greater than ourselves. To know that life is not an accident, but a universal phenomenon written into the fabric of the cosmos. The idea of finding another Earth began as a dream of philosophy before it became a pursuit of science. When Copernicus proposed that Earth was not the center of the universe, he planted the seed for a radical thought: if Earth is one planet among many, perhaps there are others like it. Centuries later, as telescopes became more powerful, astronomers began to suspect that stars too might have planets. But without evidence, the idea remained speculation, a hope more than a fact. It wasn't until the late 20th century that science gained the tools to turn that ancient dream into a real search. The habitable zone, sometimes called the Goldilocks zone, is where a planet is neither too hot nor too cold, but just right for life as we know it. It's a simple concept with profound implications. Around cooler, smaller stars, the habitable zone is close in. Around hotter, brighter stars, it's farther away. But distance alone doesn't determine habitability. The type of atmosphere a planet has, the composition of its surface, the strength of its magnetic field, all of these factors matter. Some planets in the habitable zone might be covered in thick clouds of carbon dioxide, creating suffocating heat, while others might be frozen wastelands. Still, the discovery of even one Earth-like world gives rise to a thrilling possibility that somewhere out there, under an alien sky, the chemistry of life may have found its footing. One of the most promising discoveries came with Kepler 186f, a planet about 10% larger than Earth, orbiting within the habitable zone of a small red dwarf star about 500 light-years away. Its size suggests it could be rocky, and its position means that liquid water could exist on its surface. Then there's Kepler 452b, often described as Earth's older, bigger cousin, orbiting a star much like our Sun, though a bit brighter and older. These discoveries don't confirm life, but they confirm something equally profound: that the ingredients for Earth-like worlds are not rare. They may, in fact, be common. The search for another Earth is also the search for life's signature, the subtle chemical traces that might betray biology at work. Scientists call these biosignatures, and they can appear in a planet's atmosphere in the form of gases like oxygen, methane, or ozone. On Earth, life has dramatically shaped our atmosphere, filling it with oxygen from photosynthetic organisms. If we were to look at Earth from afar with a telescope, that oxygen would be a clear signal that something alive exists here. That is why astronomers now focus not just on finding planets, but on analyzing their atmospheres. With instruments like the James Webb Space Telescope, we can study the light that passes through an exoplanet's atmosphere during transit, breaking it into its spectral components to identify specific molecules. Already, Webb has detected carbon dioxide, water vapor, and methane in several exoplanet atmospheres, hints that we are learning how to read the chemical fingerprints of distant worlds, but life elsewhere may not be like life on Earth. It might not breathe oxygen or depend on carbon. It might exist in oceans beneath icy crusts, as we suspect, on moons like Europa or Enceladus in our own solar system. It might thrive in methane seas, in sulfuric clouds, or even in chemical reactions we have yet to imagine. The search for another Earth is partly a search for our own reflection, but it's also a challenge to expand our understanding of what life could be. Astronomers must balance familiarity with imagination, looking for conditions that resemble Earth's while remaining open to forms of existence that defy it. Our tools are growing more powerful. The Transiting Exoplanet Survey Satellite, or TESS, launched in 2018, continues the work of Kepler, scanning nearly the entire sky for nearby exoplanet. Unlike Kepler, which focused on distant stars, TESS targets the closest one's worlds within reach of future telescopes that might one day image their surfaces directly. The James Webb Space Telescope, with its immense sensitivity, has already begun to reveal the chemical makeup of exoplanetary atmospheres. In the years to come, other observatories like the Nancy Grace Roman Space Telescope and the European Plato mission will deepen the search, identifying thousands more planets and refining our understanding of which ones could support life. Yet, for all our technology, the quest remains deeply human. When astronomers point their telescopes toward distant stars, they're not just gathering data, they're reaching across light years, asking the same question that philosophers and poets have whispered for millennia. What if there are others? What if, somewhere, under a foreign sun, there are oceans that reflect light like ours, mountains that rise against the sky, creatures that feel, think, or dream? The thought carries both wonder and humility. Wonder at the possibility of cosmic kinship, and humility at our smallness in a galaxy teeming with worlds. Statistically, life should not be unique. If the Milky Way holds hundreds of billions of planets, and if even a fraction of them fall within habitable zones, then the number of potentially life-bearing worlds could be staggering. Estimates suggest there might be tens of billions of Earth-sized planets in habitable zones around Sun-like or red dwarf stars. And if even 1% of those worlds develop life, the galaxy could be alive with trillions of organisms, some simple, some complex, some perhaps capable of looking back at us. Still, despite the numbers, we have yet to find proof. The silence of the cosmos, what scientists call the Fermi paradox, lingers like an unanswered question. If life is common, why haven't we seen signs of it? There are many possible answers. Perhaps intelligent life is rare or short-lived. Perhaps other civilizations exist, but communicate in ways we cannot detect. Our galaxy, the Milky Way, is a cradle of worlds. Some strange, some familiar, some perhaps alive. Each one a quiet note in the grand symphony of creation. When we gaze upward, we are not just looking into space. We are looking into a mirror of infinity, where every point of light holds the promise of a new horizon. And though we may never count them all, knowing that they exist, that the galaxy is overflowing with planets fills the night with wonder, and the human spirit with peace. As our journey through the galaxy comes to a gentle close, we are left with a sense of quiet awe at what we've discovered together. We began by looking up at the night sky, tracing the faint ribbon of the Milky Way, and wondering just how many worlds might be hidden within its shimmering light. We learned that our galaxy is not merely a collection of stars, but a vast ocean of planets, hundreds of billions of them, each one spinning in its own rhythm, each one writing its own story in the cosmic silence. From the birth of planets in clouds of dust and fire, to the breathtaking diversity of worlds that orbit distant suns, we have seen how the universe creates endlessly, effortlessly. There are planets of burning metal and worlds of endless ice, gas giants glowing like lanterns in the dark, and rocky orbs where alien skies might glow in colors we can only imagine. We have witnessed how the tools of human curiosity, telescopes, equations, and imagination have transformed what was once mystery into understanding, turning faint specks of light into living worlds of possibility. And among those billions of planets, we have searched for one that feels like home, a second Earth, not just to prove that life can exist elsewhere, but to remind ourselves that we are part of something much larger. The discovery of Earth-like worlds does not make us smaller. It connects us more deeply to the cosmos. It shows that life, that fragile spark that began here, might not be alone in the dark. Our galaxy, the Milky Way, is a cradle of worlds. Some strange, some familiar, some perhaps alive. Each one a quiet note in the grand symphony of creation. When we gaze upward, we are not just looking into space. We are looking into a mirror of infinity, where every point of light holds the promise of a new horizon. And though we may never count them all, knowing that they exist, that the galaxy is overflowing with planets fills the night with wonder, and the human spirit with peace.